Well, welcome everybody. Appreciate you taking the time, trekking out to the far end of the Mandalay Bay here, or the folks watching at the Venetian, to have a fun conversation around Zero Trust. My name is Quint Van Diemen. These days, I'm a principal in the Office of CISO within AWS Security. But for about the last 3 or so years, I have found myself sort of in and around the mix of the Zero Trust conversation at AWS, which has been a really fun evolution of sort of us gathering our thoughts around this nuanced security topic, and then working with you all on how we use that to build better security. And that's what we're going to talk about today. I'm really pleased to be joined by the folks at Delphix, right? And they'll introduce themselves when they get up here. But Jeff and Pritesh are going to show you how this works in real life. But as we get on our way there, we're going to go through a couple of things, which is really how the conversation between we and great customers like you has really evolved, right? Well, first, kind of ground everybody. I know that sometimes there's so many competing definitions that definitions just get in the way, and they that's not what we're going to focus on. But we'll at least ground quickly on sort of the definitional level of Zero Trust, maybe with some fun metaphors thrown in. And then we'll get into the meat of things, right? We're going to talk about how we've woven Zero Trust principles into the fabric of AWS, right? The Zero Trust that you just get from consuming the platform. We'll then talk about a couple of use cases where you can build Zero Trust compliant architectures on top of AWS using our various services and features. We'll then again go to Delphix, and we'll hear how they've some of the great outcomes they've been able to achieve by doing this in real life, and maybe finish up with a few other real world examples that you can use for inspiration. Right? And so this is the question that we sort of started with as we started getting into Zero Trust. And actually, this is really just sort of the fundamental question that we have been helping our customers with from a security standpoint, really since the dawn of the cloud, right? It's just, how do I keep my system safe and secure? And we really like this question because it's super practical. It lets you drive towards meaningful outcomes, and it avoids sort of the hazard of the academic, is this zero trustworthy enough, right? But eventually, customers and the sort of the world demanded that we have a more formal opinion on this subject, right? And so we came up with this definition, right? And it's not, definitions are what definitions are. This one I think is fairly broad, but it gets to the heart of things in my mind, right? There's a couple of key things that I'll tune you into there, right? One is that we really think of this as a security model, right? This is a way of thinking about security. This is not necessarily a product, right? You might use products from AWS and others to implement Zero Trust, but it itself should be a security model, right? We then kind of get into the do not solely or fundamentally depend on network perimeters, right? You'll hear this echoed just pretty much anywhere across the industry when you're talking about Zero Trust. We want to bring in additional context, identity, device, lots of other signals, and do increasing levels of granularity and sophistication on our authorization decisions, right? So let's get past the definitions though, right? I like working things through metaphors. This one may resonate with you. Maybe it might resonate with you as a way to explain Zero Trust to somebody on a board or an executive level that you might be working with, right? Most people go with the castle and moat, and I don't, that one to us doesn't really work super well because it's really only giving an example of what was wrong with the previous world. Let's go instead to something like an art museum, right? And I'm going to give credit where credit's due. My colleague here, Saeed Sharif, over on the control tower team, really came up with this, and I just, it was mind blown when I heard about it, right? But you think about what an art museum is there to do. It's filled with priceless works of art, but it absolutely, its whole value is getting people inside to interact and experience those things, right? The building's exterior is still incredibly useful, right? It keeps out the wind, the rain, the other things, the snow, but it allows the staff to set sort of proper environmental controls, right? All that great thing. But the crux of the security comes from the museum operating as a system of norms with explicitly directed behaviors, right? Ubiquitous monitoring and observation and detective safeguards. And so while there are many spaces of the museum where one can roam relatively freely, As you get closer to those priceless works of art, the preventative controls, right? The ropes and signs that tell you what's permissible and what's not. These are often quite literally bright red lines with normal behavior on one side and abnormal behavior on the other, right? Cross the line and security quickly engages to draw you back in to the normal pattern so they don't have to escort you out. Yet, those security personnel aren't obvious, right? They aren't standing at every corner overwatching everything you do in overwhelming numbers. That would sort of destroy the ambiance of the museum, right? Instead, their actions are triggered by a wealth of sensors, right, that are ensuring the preventive controls are operating as they intended, right? Cameras, doors, sensors, more. And that way they can reside in the background, yet quickly react in targeted ways when needed. And then finally, safeguards, right? Because every so once in a while, a would-be vandal, or probably more likely a toddler out of reach of their parents, might go beyond one of those velvet ropes, right? And as they get closer, the detective controls kick in, right? Fancy stuff like laser boundary detection, touch sensors, loud alarms with sirens and strobe lights, right? And when those go off, they draw immediate attention to everyone in the museum, right? To that exact spot, right? With the very intense scrutiny, right? That goes to the general museum staff, even the museum guests, right? All eyes sort of quickly pivot there, watching sort of probably that mortified parent regain control of their little one. So are the doors and windows locked at night? Of course they are, right? But when the museum is open, right? When it is using the art inside to provide value to the guests, we really see how the security of the museum works, right? How it balances the security of the art with the enjoyment of the art by operating as a system of norms, right? A system of expectations, of observability, and response plans. And so, with a little bit of, sort of metaphoric liberty, we'll call this zero trust in the real world, and hopefully it'll be a reasonable conveyance into how we look at that in the digital world. Okay. So the next thing I want to walk you through, again, quickly, are sort of how we think about zero trust in terms of some guiding principles. And if you've been in and around Amazon for a while, you'll know that we like to talk about these things in terms of tenets. It gives us sort of better clarity to how we get our heads around a complex topic, probably better than the definitional level stuff. And so the first guiding principle I want to offer to you is that, you'll hear all of this, the network perimeter is dead, right? Long live the identity-centric perimeter. That's true, but I think it's a little bit of a false choice, right? While network perimeters, well known that they're sort of no longer sufficient, and we've got to do, more fine-grained identity-level controls. Those network controls are really well understood. There's a lot of corporate knowledge. There's a lot of infrastructure that's been there that we still ought to take advantage of, right? They can provide a good outer set of guardrails within which the finer-grained identity controls can operate. And ideally, those two things not only work together, but they are aware of one another, right? And a great example of this in AWS is something like a VPC endpoint. It's a control at the edge of your network that can reason about the identities and the resources that are flowing across it and write policy that actually incorporates all three, right? Really, really great patterns. The next guiding principle, and this is the token, like if you only take away one thing, I hope this is what you take away, is to focus on use cases, right? These are the three use cases that we sort of broadly characterize things as, right? Machine to machine, human to application, and digital transformation. But what's sort of really interesting about these use cases is that they all share those same fundamental underlying principles, right? The same technical principles. We need to be using identity in greater context and more stringent evaluations. But the outcomes that these different use cases are after tend to be radically different, right? We'll look at them each as we sort of get into things today. But first one might be about ensuring that we eliminate unnecessary pathways to data. The second might be about increasing our users' mobility, right, and their workforce productivity. Right? So if we focus on the problems we're trying to solve, it sort of naturally steers us back to that first question and out of this hazard of getting mired into some academic discussion about, is this zero trusty enough, right? You focus on those use cases, you work backwards from them, you get better security every day, and we can use zero trust as sort of the North Star or the goal line, right? And then the last guiding principle, right, is that this still is not one-size-fits-all technology. I think that's true of a lot of security in the cloud, that when, it's really easy to think about wanting to issue these broad and flexible mandates, but there's just a sort of a reality that we're still in a bit of a nascent state with Zero Trust, right? There's still some effort that you're going to have to put in, and that's absolutely effort that we believe you should put in where the value of what you're protecting is worth it. It's not probably worth it to just broadly do it everywhere. You're going to slow yourself down, and you're going to create friction in your organizations and not get the lift you expect, right? Okay, so now let's flip into sort of Act 2, right? What are some examples of Zero Trust within AWS? Again, the part of Zero Trust that you just get as you consume the platform. So the first example here, right, is just simply literally interacting with AWS APIs, right? Something that you all as customers do each and every day. Probably a good portion of you over the world's most untrustworthy network in the world, the internet, right? And why do we do that safely and securely, or how do we do that safely and securely? Well, no great magic here, right? We've got transport level security provided by TLS. That gives us good, confidentiality over the wire. And then on top of that, we're going to take AWS's signature v4 signing protocol, right? Now, a lot of this is generally abstracted for you by the CLI or the SDK. You never really thought about what was going on here, but each and every one of those requests that you issue through the console, through the CLI, what have you, is individually signed using your security credentials, and then we uniquely authenticate and authorize every one of those requests, right? And this happens to the tune of 500 million requests per second globally, which is just sort of bonker scale, right? And what's sort of been interesting to us as we've watched this Zero Trust conversation evolve over the years is sort of no one ever talks about cloud APIs as a use case, that's really Zero Trust or implicated, right? And maybe that's just sort of, this is the way it's always been, but curiosity nonetheless. So now let's talk about how AWS's services operate with one another on your behalf, right? It would be really easy for us to say, hey, these are all things in our world, and we're going to give easy liberty to make things work seamlessly with one another, but that's clearly not what happens, right? Instead, let's take an example. Let's take auto-scaling here, right? And you're in your AWS account, and the auto-scaling is doing its job, and it figures out that this compute fleet is a little bit low on CPU or memory, right? That triggers an alarm. That's going to go off, and it's going to trigger an action in a different AWS account, the auto-scaling account. And in that auto-scaling account, there's going to be an IAM role. Now, we call it a service principal. We give it a bit of a different name, but it is absolutely the exact same IAM role that you use each and every day in your accounts. There's also a role where you've given us permissions through what's called a service link role in your account. And then that auto-scaling service principal does the exact same STS assume role operation that you do into your account, gets back a set of temporary credentials, and then uses those to SigV4 sign, just like you do. The request that goes up to the EC2 endpoint, it gets authenticated and authorized by AWS IAM, just as your requests do. And then and only then does that new infrastructure get dropped into your account. And so the punchline is that we ourselves are using the exact same identity-centric mechanisms to authenticate and authorize our service interactions with one another that you use, right? Okay, so now let's flip into Act 3, right? Where we're really going to start getting towards building some stuff. And now we're going to talk about how AWS can help you on your journey to building Zero Trust, right? And like I said, we're going to do this in with the backdrop of 3 specific use cases. The first is going to be machine to machine, right? People will talk about like reducing east-west mobility within Zero Trust quite a bit, right? They'll call it micro-segmentation, micro-perimeters. But what we're really trying to do ultimately is reduce the surface area of the systems as they connect through things, right? And we particularly want to understand pathways that weave through our data centers, virtual or otherwise, and particularly ones that lead to data, right? And then the consideration, and I will say this consideration is maybe changing a little bit, but at least looking backwards, the patterns have followed the architectures. And what I mean by that is the way you might do that on EC2 is a little bit different than the way you might do it on containers, which is maybe a little bit different than the way you might have done it with serverless, right? Okay, so let's start, and we'll do this with a backdrop of just a simple application. And we're going to see this application throughout our time today, and it'll sort of evolve and twist and turn. But this is internally an application that sort of every Amazonian will always reference. It's called Phone Tool. It's nothing more than our corporate directory of who works for who and things of that nature, right? And so we've got a standard 3-tier application here to start. It's got its load balancer out on the front. It's got a set of compute in the middle, and it's got a relational database towards the back, right? And so the first tool in the kit bag for zero trust in an architecture of this nature is the good old-fashioned security group, right? Now maybe you have, hopefully you're not, glazing your eyes over about me talking to you about a feature that's maybe from 2008, somewhere thereabouts, right? But security groups have some really amazing properties to them, right? As I've sort of drawn here, you can tightly couple and chain the security groups to one another, right? They grow and flex as the infrastructure comes and goes without you having to do anything to them, right? They have this notion of membership that allows them to just flex around the infrastructure. And then you can write simple rules that reference one from another, and it's sort of implicit in the diagram there, right? But I can say that the only thing that's allowed to talk into the web server security group is the load balancer associated with that same application. And the important takeaway there, right, is that if we do this pattern right, if we chain these security groups together, workload by workload, what we find is that everything is implicitly denied, right? So we've gotten ourselves to a place where, sure, we're still talking about network level flows, but we've gotten to a place where we're not trying to lock down east-west traffic. We're already a place where everything that should go across the network is explicitly defined, and anything that's not explicitly defined is implicitly denied. Right? So now, applications are rarely that simple these days, right? And so maybe our application has added some enhancements, and those need to come from a set of containers off in some other team's AWS account, right? Well, we might turn to a service like Private Link today, right? So Private Link allows you to create this one-way gateway through sort of the fabric of the cloud between VPCs that are otherwise unroutable, right? And it provides us just narrow one-way path sort of through the wormhole, if you will, that, again, it's sort of that same principle that we're very explicit in what should go through there, right? It requires great two-way handshaking so everybody understands what's going on. But there's literally no path at all between two things that don't have any need to talk with one another, right? And I think that is just a radical simplification, right? It's a lot easier to secure a path that doesn't exist than trying to constrain one down. Now, on top of that networking control, a customer might choose to run a layer 7 protocol like OAuth or mutual TLS, maybe with some open policy agent thrown in there, right? There are a lot of different options here, and this one's sort of showing a more standards-based approach to how you might layer 7 identity on top of sort of an explicitly defined layer 3, layer 4 network. The same solution is actually how we connect in many of our partner services. Like if you've used a database from Snowflake or others, right? They're using this same technology to land their endpoints in your VPCs. Pretty good cloud magic, right? Okay. So now let's modernize this application a bit, right? Let's take away that old relational database and let's maybe put in something like Amazon DynamoDB, right? We're going key value. Well, the first thing we're going to do there, DynamoDB is an AWS API. We talked about how those requests need to be signed as they go up to our service. So we're going to attach an IAM role to the auto-scaling group there. And AWS is going to do probably something that you've also not really thought about much because it just sort of happens silently in the background. You don't really think about it much. But we are delivering and rotating credentials on your behalf to each of those instances every hour. Right? People talk a lot about like fingerprinting and secrets management and credential distribution. This just happens, right? And we can do this because we have the root of trust, right? We know what the instances are. We know where they where they're running because we put them there and really solve a lot of hard problems for you. Right? So we'll SIG-V4 those requests using those credentials up to DynamoDB. We'll use that VPC endpoint that we talked about before to really constrain down what's sort of flowing across that network boundary edge, right? And we're pretty happy, right? But that was for AWS APIs, right? Now, what do we think? Well, now, what might we do for your own APIs? Well, it turns out that Amazon's API gateway, right? It can support the same type of authentication authorization. So you create your API, your VPC endpoint for API gateway, right? It flows through a security group as well. You put what's known as a resource-based policy out on your API endpoints. And now AWS is doing both halves of the, or layer 4 and layer 7 for you, right? You've offloaded request level authentication authorization onto that system that I talked about before that's doing 500 million requests per second, right? And again, there's no path between things that don't need to talk with one another. Everything, again, still very explicitly defined and implicitly denied, right? And really some kind of cool 5-star cloud magic here, right? All right. And then, the last part of this part of the story, right, is, it's very regularly that we'll talk about how to do anomaly detection, right? We want to understand what's normal, what's abnormal in these type environments. So in the background here, right, there's all sorts of great instrument or observability and logging that's going on, right? We can talk about VPC flow logs, right? What's going through your various VPC networks. You talk about CloudTrail, right? Your recording of all the API calls that are coming out of your environment. And there's a service known as GuardDuty that can centralize and work through and do threat detection on all those various sources, right? This is us doing, people will talk about doing all sorts of behavioral analytics and all sorts of complex ML. We've done all that for you in GuardDuty and just vend you out findings that are curated, right? But in this case, right, if we see something maybe we don't like, right, an unfortunate incident happens, things happen, things go bump in the night, where we get something that's not quite right on one of these instances, right? The first thing that somebody's generally going to do when they land a little bit of foothold there, right, is they're going to start sniffing around, right? They're going to run maybe a port scanner. They're going to start feeling around to what else they can see. Well, GuardDuty understands that that is all of a sudden outside of the bounds of expected behavior. It triggers a rule, and we can go into a combination or sort of your choice of human or automated remediations, right? We might fire a Lambda function. We might do some notifications out, right? But we can move that problematic instance over into a quarantine security group. We can rip the credentials out of the bottom of it, and we can go and trigger our broader incident response plan. Right? So now this is not in line, right? I think a lot of folks that talk about sort of behavioral analysis in line, right? I don't know that as we look at the intersection between availability, performance, and security, right? There still are some meaningful trade-offs here. So this is doing it out of band, but I think that we see that as a really effective way without sort of sacrificing performance and availability, right? Of getting towards this detective controls for anomalous behavior. Cool. So with that, I would love to turn over and welcome to the stage Pratesh and Jeff from Delphix, and they're going to talk to you a little bit about how they put this in real life. Awesome.
Thank you so much, Quint. Good afternoon, everyone. I'm going to start by asking a question to our audience here. Raise your hand if you have successfully implemented a zero trust architecture. A few. That's great. A few. How many of you have or are in progress of implementing a zero trust architecture? A lot here. And I'm sure others haven't started this journey yet and they want to start it soon. Brief introduction, my name is Pratesh Parekh. I head up the product development and the security office at Delphix. With me, I have Jeff Dutra, who leads engineering and architecture at Delphix. Our goal for today's session is to share with you how we implemented zero trust architecture at Delphix. I'll start with a brief business context, share with you some of the key principles, zero trust principles that we applied, business outcomes, and then Jeff will go into the implementation details. So a bit about Delphix. We are an enterprise software company based in Redwood City, California. We help companies accelerate digital transformation with our DevOps data platform. We automate the process of releasing the software faster by delivering virtualized and compliant data across the application lifecycle. Instead of relying on complex processes and multiple IT teams to manually move data across the systems, Delphix software integrates with DevOps workflows and automates data delivery and data compliance. We have leading customers across all industries, leveraging exabytes of data on our platform. So a bit more context. For this case study, we're going to focus on Delphix as a service and the zero trust architecture that we implemented for this platform. Delphix as a service is a unified platform that supports data compliance and data delivery as a service for SaaS applications and PaaS databases. The first offering that we built on this platform was for data compliance for Salesforce. Salesforce customers can leverage our service to mask the Salesforce sandbox data and make the data secure and compliant. This platform is hosted in AWS and built using a microservices architecture. There's a clean separation between the general microservices and the services that is processing the data. Data is processed in memory, and there's no persistent storage of customer-sensitive data. Each microservice has its own VPC, and there is no implicit trust between the services. It's a multi-tenant architecture, and there is complete isolation between the tenants. Data is encrypted at rest and in transit at all times, and most of the services, native AWS services that we are leveraging, are serverless. Now, I think Quinn mentioned about the definition of zero trust, and zero trust goes all the way back to Jericho Forum and Google's implementation of Beyond Trust. Since then, there have been several definitions out there. Never trust, always verify, no implicit trust, and many others. The way we thought about zero trust is a security discipline that treats every component, service, and a user of a system as continuously exposed to security risk, and therefore doesn't make any assumptions about their integrity. A simple example on how an engineer would process this on a day-to-day routine basis. If an engineer is designing a microservice, they have to assume that the microservice will be continuously exposed to security threats, and hence a walled garden approach to security may not work. Now, I want to share the 3 key principles that we followed to accomplish zero trust. The first one is, do security fundamentals really well. As we were going through this journey on implementing zero trust, our goal was to make sure we're not slowing down our innovation. We're not making our employees' job harder. We started with focusing on basics, taking a layered defense approach, and making it as hard as possible for adversaries to break in. A simple example of this is a web application firewall, a basic control, but doing it really well. Making sure WAF rules are well written in the context of the application, it has been thoroughly tested, and it can block real threats. We also applied the rules of least privilege. So in our case, there's no direct action to our production environment. There is no direct VPN connectivity to the backend systems. No engineer's laptop have access to data processing. And we use temporary bastion host and break glass approach for our support teams to have access to the systems. We also designed our data stores to have no routes to the internet. We use the approach of single-run containers and one-time jobs to deploy changes in the production environment. We've also implemented strong separation of concerns. So our dev, test, and production environments all have the same architecture, but there is no interconnectivity or implicit trust between the environments. The second key principle here is authenticate and authorize every interaction. By design, each microservice, before processing a request, validates user identity and tenant identity. Microservices do not have direct access to tenants' data. They assume tenant-specific IAM role as a result of tenant interaction. User-to-service interaction authorized using Auth, and we use Cognito for that. Every microservice authenticates to the other microservice through an API gateway, and we use custom authorizer for that. Essentially, no access to other services except for the interfaces that we've designed. And the last key principle here is simplify the security stack. As we are going through this journey, our goal was to keep it simple, reduce management overhead, and have a high signal-to-noise ratio. Key native security services that we leveraged are AWS WAF for application firewall, Shield for DDoS protection, GuardDuty for threat detection, Cognito for tenants identity management, CloudWatch for observability and monitoring, Secrets Manager for managing credentials. And for proactive enforcement of security controls, we leverage conformance pack, config, and Lambda. We enforce the security standards that we established during the process. And then leveraging the native services ecosystem and data source integration among services helped us get the holistic 360 view of our security posture. And then finally, the business outcomes after implementing Zero Trust. The policies, standards, and processes that we establish to build the Zero Trust architecture created a strong foundation for our security program. At Delphix, we take the approach of security as a team sport. Everyone at Delphix contributes to the overall security of Delphix, our product and services. Having a strong security culture is critically important to the success of our security program. And with Zero Trust and the business importance of having it, there was a good level of security awareness across the organization. It also demonstrates to our customers that we take security seriously and build stronger trust and confidence with them. Another outcome was getting the security certifications and attestations done. The key controls we implemented as part of Zero Trust made our audits go smoothly without any significant roadblocks. And then finally, having Zero Trust helps reduce the friction in the sales cycle. The policies, procedure, and technical controls we implemented as part of Zero Trust mostly addresses the common concerns from our customers. So I'm going to hand it over to Jeff, who's going to go over detailed implementation and architecture.
Thanks, Pritesh.
Thanks.
So let's get started with looking at our Zero Trust components with the Delphix architecture. So first and foremost, we are a cloud-native architecture with serverless and as-a-service first designs. And this helps us on our Zero Trust posture because we can be as granular as we want to be when we talk about our Zero Trust posture. First, next, let's talk about our network components. We use virtual private cloud, VPC endpoints, and TLS encryption for all communication. Next, our identity components. We use IAM, Cognito, and the Delphix custom authorizer, which sort of ties the two together. And that ties in natively with all of our cloud-native components that we're using within the system. Next, let's talk about our network segmentation and our network design. So we use service-level network segmentation, and every service resides in its own VPC, with least privileged security group configurations on every service. Services do not have any direct communication within each other. Our VPCs have identical overlapping IP space, so we couldn't peer them even if we wanted to. Next, our database subnets actually have zero access to the internet, so they can't be exposed directly on the internet. And finally, for service-to-service communication, we use VPC endpoints to be able to talk to API gateway and back to the next service for more granular network controls at every layer. Next, let's talk about our Zero Trust identity that we have set up in the system. So services all have their own IAM roles. Tenants also have their own IAM roles. A user will authenticate into Cognito. And within Cognito, a user has custom attributes associating them with their tenant UUID. When a user authenticates, they receive their JSON Web Token, or JWT. And when they receive that, within that JWT, you'll see that there's a tenant UUID there. When they make the subsequent request to our service, they pass along that JWT. The Delphix custom authorizer verifies the JWT, then allows the customer to STS assume role into the tenant role, and now the application can operate as if it was them and access tenant-specific resources like S3 buckets, KMS keys, or secrets. So now let's talk about the Zero Trust identity for service-to-service communication and how that works. So we have service A, and it'll operate within its role, and it'll pass along the tenant's JWT with the transaction. They'll use SIG-v4 authentication using the service role to the second service. From there, the jot is verified, and then it allows the tenant to assume role to the tenant role. That tenant role has an IAM policy, which grants it access to specific tenant resources, such as KMS keys or S3 buckets, etc. And now they can do SIG-v4 authentication using the tenant role to access those resources. Next, let's kind of talk about the whole auth flow and how it all ties together. So first, a user is authenticating to Cognito. They receive their jot. They hit the API gateway with the jot. It sends the transaction over to Lambda. Lambda is going to inspect the jot and verify it, allowing it to assume role into the tenant role. Now the service A is going to do whatever work it needs to do to function, but let's say it needs to talk to service B now. Service A is going to go ahead and make a call to the VPC endpoint, to the API gateway, and using the service role, do a SIG-v4 authentication to the second Lambda, passing along the jot with that transaction. That jot then, again, gets verified, and then allows that service to assume role into the tenant role. And now that service can access the tenant-specific bucket for the using SIG-v4 authentication. So what are some considerations that we had to go through when we did this? So we're heavy users of CI/CD, given kind of what we do. And so for CI/CD, you have to think about heavy scrutiny on anything that deals with tenant identity, or in this case, our custom authorizer, for instance. You need to have extra scrutiny on it. You also need to think about the roles in which your CI/CD pipeline is going to be functioning as. In addition to that, you need to think about account quota limits. So for us, because of the level of granularity that we chose within our zero trust posture, we have a bucket per tenant and IAM roles per tenant. In order to scale, you will eventually need to support multiple AWS accounts. Next, I want to talk about the cloud-native benefits and how that ties into our zero trust journey. So for us, serverless allowed for very granular zero trust policies, which, for both network and identity. Serverless and cloud-native services mean that we don't need to do common maintenance tasks, and we can focus on our application and our zero trust policies instead. Also, Cognito handles authentication natively for us, so we don't need to build our own identity provider. And KMS for encryption and ACM for certificates means we don't need to manage our own PKI infrastructure. And because it's all cloud native, there's native AWS services have direct integration with other zero trust components for ease of implementation. So I'm going to go ahead and hand it off to Quint. Thank you all.
Awesome. Thanks, Jeff. Thanks, Pritesh. I really enjoy seeing that both come to life in the architecture and really just sort of cementing some of the great outcomes that you all have been able to achieve. Now, there's a little bit of hazard when you're in and around AWS, and that is the state of the art changes sometimes very rapidly, right? And that happened this week, right? So we've been talking about how you might build these zero trust architectures in a rearward-looking way. But earlier this week, we came out with an exciting new thing, right? Something I think is really going to set the new bar for how we're going to do this service-to-service use case, right? So what if we could stop worrying about eliminating unnecessary pathways through the network, and we just stop worrying about the network entirely, right? And that is what Amazon VPC Lattice is going to do for us, right? If you didn't catch it in the networking leadership talk earlier this week, Amazon VPC Lattice is essentially a way to, the folks that build it will really talk about it being a network simplification for developers, right? They want to be able to connect all forms of different compute in a very consistent way, right? Sort of get rid of that patterns follow architectures thing that I talked about before. We're gonna dive in and look at this one, which is, I think, the real big security lift, right? Is about how we can apply granular access controls. And then there's a lot of other great, sort of developer-centric features around, how traffic gets routed, how traffic gets observed, and it really is just a great streamlining of everything, right? But let's look at it sort of in practice, right? And so we've got our two services here. We're going to start with two services in the same VPC. One's running there on EC2, and the other is running on a container, right? And so the first thing I'm going to do is I'm going to associate that VPC with what's known as a service network, right? And what that does is it creates this space at the bottom of your VPC. It's link local address space. It's impossible to route to it. Like literally nothing can exist there except the AWS Lattice service, right? And what that allows us to, or the next thing we're going to do is put a security group on these things that basically says nothing can go, nothing can come in, right? If service A then needs to call service B, right? It's going to do that in the way it would normally think about doing it, right? Whether that's a HTTPS call, right? It gets a private name, DNS name for that service, so the developer doesn't need to know that it's going down here. But that request essentially DNS resolves to this link local space, the wormhole at the bottom of the computer. Right? And it goes into the Lattice service. It goes through all these service definitions. It understands, what's, where things get routed based on, a whole bunch of service definitions and target groups, right? And then it pops back out the wormhole on the other end, right? And drops back into the bottom of the computer. We can span this out across if we have multiple services and we want to span those across accounts, across VPCs, right? All of it works the same way, right? And then what you see, which almost the best thing about this diagram is what's not here, right? There's no private link. There's just this radical simplification while still using that same concept, right? There's just fundamentally not a path between these things. But then, we probably already had those IAM roles attached to these various flavors of compute. We were already using those to go off to DynamoDB and our other AWS services. But now you can take, and while you were able to do this before with API Gateway, now you can sort of do the same trick across any flavor of compute, across any front-end component, right? And so you use your IAM role. The AWS SDKs help you do the signature v4 signing process for your services in a straightforward way, and then you get to write IAM policies that go into the Lattice service, and those have to essentially check out for the bits to get where they need to go, right? And so we have our callers; they send in SIG-v4 level requests. We do all the checking, all the authentication, authorization on a per request basis as things fly through the wormhole, and then what spits out the other end is an HTTPS connection like you'd expect, right? And so this concept, right, that where we've taken, before you could get rid of administrative ports in your compute environments, like, using services like SSM, right? We got rid of port 22, rid of 3389. This is essentially a way to get rid of your service level ports, right? Once we, maybe there's some migration period in between, but once we get fully onboarded to a service of this nature, literally just the security group says nothing is allowed in except if it comes from this special little space at the bottom of the computer, right? So what do these policies look like? These policies look exactly like the IAM policies that you've been using for quite some time now, right? Love or hate the JSON interface. You can see there that we're sort of describing our principles as the IAM roles that you are, again, already attached to your compute instances. There's a very, you can do sort of using that resource line, you can authorize things down to very specific paths in very specific ways. And then there's a ton of what are known as service-specific context keys, right? And so you can do a really elaborate set of filtering for things, about, only allowing certain response types, only allowing certain HTTP verbs. Like there's just an ocean of possibilities there. And then lastly, because we're using IAM, yet again, like this sort of authorization system across all of AWS, you get to piggyback onto some of maybe the governance controls that you might have been using for other parts of your organization, right? Like being able to specify a guardrail, like I want to make sure, even if I dork up the policy in the top half, nobody, no principals outside of my own organization are going to be able to make this request, right? And it's a good sort of checks and balances, belts and suspenders. So I really think like this is, I recognize my bias, but I think this is like probably got to be my favorite release of reInvent this year, because it just to me is welding the computer shut, right? Like, if one of those unfortunate incidents happens and something manages to find its way in and they start scanning around, they're going to just find a ghost town, right? There's literally no ports listening on the network. And that to me is just super incredible from a security point of view. Okay, so if you want to learn more, there's a great session tomorrow afternoon that's going to go into Lattice in full and glorious detail. I guess it looks like 12:30 there. And then if your reinvent navigation is and your walking speed is really dialed up, there's a chalk talk. I think it's over in the MGM about a half hour after we wrap up. So that one might be a little hard to get to, but go check out that breakout. Okay. So now we're gonna switch and we're gonna talk about a second use case, and this is probably the one where a lot of people will start with, right? The any human accessing a private application from any coffee shop in the world. Our goal here, again, back to that thought that we're trying. Our goal in these various use cases may vary. We're really about workforce mobility here, right? When Amazon rolled this out for ourselves, right, that was absolutely what we were after. We wanted our fleets of, or our many numbers of on-call engineers to be able to do their job from their son or daughter's soccer game or swim meet or whatever it might be, without having to run back to the car and grab the laptop and the VPN if they got a little bit of an alert, right? And so certainly we want to make those internal applications available anywhere, but while maintaining or improving our security posture, right? And then the sort of consideration here is, again, that it's sort of not a one-size-fits-all scenario. We'll walk through a couple of different ways that one might do this, but there are some companies that really want to stick things on the internet. They do that each and every day. They're quite confident in that. And there's other companies that is terrifying to, right? And we have different ways of solving it. So let's look at sort of the first way that we might have gone about this use case, right? We've still got our same employee directory application that we've been talking about for a while. We've changed it subtly, that we've got sort of the back end of things in a private subnet, but we've put the load balancer that we already had, now we've put that up into a public subnet. We turned on OpenID Connect within the load balancer, right? This is sort of a checkbox and minor configuration type of exercise within the ALB. And then we might have wired up some services in front of that, something like Shield and WAF, right? For protecting against the various unpleasantness that is out on the internet, right? And so when a remote user comes in, they obviously hit the front end of that load balancer. They haven't been authenticated, and we're going to bounce them to the identity provider. Any identity provider, it's OIDC compliant, right? Where we do all sorts of. Apologies, it sort of looks like it went off the screen there, but it's going to do all sorts of strong and adaptive authentication of the user, of the device, et cetera. And then only then does the request flow through. And what's sort of neat about this is there's benefit to all parts of the organization, right? The end user is getting what they want, right? They're getting this SaaS-like experience for their internal apps. The security team didn't have to build a whole bunch of apparatus, right? Like they're just getting managed protections from AWS. And then the developer on the background gets sort of a free upgrade from old crusty application identity, things like Kerberos, to more modern standards like OpenID Connect. All right, but like I said, that's not for everybody, right? I was talking with a customer just earlier today that really felt much more comfortable with this pattern, right? And their reasons were very well framed, right? And so maybe we don't want to stick our employee application directly on the internet. We can use the pixel proxy approach, right? It comes in a number of different flavors. We might use workspaces. We might use AppStream, right? But the same sort of dance applies here, right? We through a control channel, firmly authenticate the human. And what we get is this, this breakpoint, right, where the apps and the data stay nice and tucked in the cloud, and then what gets sent out to the remote users is just a pixel representation, right? And this works particularly well, right, when some of our folks aren't armed with corporate laptops and VPNs. These patterns still come to bear. But in either case, we still knew we could do better, right? We still wanted, both of those still required a little bit too much assembly, that we still, we were doing better security than before, but we still probably weren't to a full, what most folks would consider zero trust bar, because some of the checks around device, some of the checks around identity, they were kind of happening once per application rather than once per request. And we weren't maybe considering the full context of what we might evaluate, right? And here again, right, state of the art changed a little bit this week with the announcement of verified access. And so verified access, right, it is going to be sort of a rehash. It's going to be our modern way of doing, of providing access to private applications in your VPC. You'll see many of the benefits that sort of, we've been talking about through this use case already, right? About improving mobility while not letting down our security posture and simplifying the sort of operations in the middle. All right, so what does that look like, right? So we'll start with where we left off with the ALB example. We'll drop that public subnet, and we'll put all of our components back in our private subnet. It looks like taking away WAF and Shield, but think of this as AWS managing WAF and Shield for you, right? And we'll drop in verified access as an endpoint, right? And so now the remote user comes in, but this time we send right along the wire through a browser plugin, device health and posture information from a variety of leading endpoint protection agents, right? CrowdStrike, Jamf, and some others, right? And we get that up. We can do sort of PKI style, stateless verification of that information, using good cryptography and understand the state of the device. We still rely on the identity provider, right? We don't want to be duplicating that for obvious reasons. And we go and we do our strong authentication of our human, maybe using something like a FIDO2 authenticator, right? Nice and phishing resistant. And then we have all sorts of other sort of bring your own context that you can plug in. If you've got some super fancy behavioral system that you want to consult, if you want to consult any system of yours, and you can write policy on top of any of that context. So you bring the context, we give you the language to evaluate and run the rules over top of, right? And then only then do we get back to the application as before, right? And so this is sort of my managed protections plus. Again, just sort of it's simplifying, making all of those evaluations occur on a request level rather than per app, and just getting more to those pure principles of zero trust. So another awesome release that I'm super excited about, right? So maybe this is a little bit of there's some. Largely the same sort of premise as the slide before, but just a few kind of extra things to sort of double down on and talk to here, right? And probably the key one is down in the bottom right there, is that what this system is designed to do is let you use the security services that you've already got, right? Maybe in some ways that's a lot of what zero trust really is it's the weaving together of a whole bunch of classic security problems and security solutions in a way where everything works together more seamlessly and with better interoperability, right? And so we're really building verified access as an open ecosystem, right? The integrations aren't closed, and so we'll continue to build more to provide a better sort of out-of-the-box experience. But again, you've sort of always got that safety valve. If you want to call out to something unique, you don't have to wait for us to build it. You'll always have that option. So now, unless you have a time machine, you're going to have to catch this one on YouTube after the fact. This one was, I guess, a little bit earlier today. But again, another great breakout that will go into verified access in all sorts of detail, right? Okay. And then, our last sort of use case, again, and I'm going to sort of touch on this one quickly, is around digital transformation, right? Think of this as the proverbial wind turbine out in some hot, dusty place somewhere, maybe in the middle of an ocean, that obviously exists well outside the corporate network. We've got to have a security model that accounts for those, and obviously something based on network perimeter is not going to do very well for us, right? If you're not seeing IoT or other sort of digital transformation use cases in your environment today, I'll tell you that it's probably coming. Increasing number of industries and customers that sort of never would have been logical to think about really are seeing these crop up as great new innovations in their companies. And so, we won't dive into that one, terribly deep, because you really, if you went and you watched a great talk about how we think about IoT security, OT security, that's where you're going to get sort of the details there. All right, so I want to wrap up with a few additional real-world examples, right? So the first one, and you can give me a little bit of a ding for using an Amazon example in an AWS talk, right? But Amazon Lumos is the next generation payments platform that sits underneath Amazon.com and our various global marketplaces, right? And I won't go through all the gory details. Like if you want to actually hear their talk from reInvent the, I guess it was last year in 2021, the link is there, right? But this is the system that's handling credit card transactions. It's doing operations like tokenization. Like this is operating on some of Amazon's most critical data. You can kind of see a lot of the patterns that we've talked about throughout, right? Gateway, WAF, shield, containers accessing through private link. But sort of the big punchline on this slide is that API endpoint that the rest of Amazon.com needs to call is sitting out on the internet. Like for people that say you can't put stuff on the internet securely, like the Amazon.com tokenization APIs and credit card processing APIs that Amazon.com uses to ship, your paper towels to your door in hopefully a day or less, right? Like it's sitting out on the internet, and it does so again using all this what we've been talking about. Another great example, right? Goldman Sachs, they put together a system called Transaction Banking as a Service. I'm not nearly smart enough in the financial world to know exactly what that means, but it sounds super regulated, super complicated, and definitely dealing with a very high degree of sensitive data, right? And again, sort of same patterns here, right? You're seeing private link exposed container services. I think they used mutual TLS because that's what they were familiar with, right? But again, this to me is a great example of a big regulated production workload using exactly these principles. So, I think that sort of brings us towards the end, right? And, I guess what hopefully you saw from the great work that Delphix presented from, Amazon Lumos, from Goldman Sachs, hopefully you saw some of these patterns sort of come to life. You probably noticed that they were each one of those was a bit of a different manifestation, right? And, while that means that there's not quite a shrink-wrapped approach on that, I think that's really healthy, right? That lets you take these principles that we're talking about, take these reference architectures, and adapt them to the workloads that you have and that you will have in ways that really lets you just up-level your security. So with that, I really thank you all a ton for coming out. I know everybody says it, but I really would appreciate if you would take the second to do a little bit of a feedback through the app on how we did today. We'll, I think, gather outside if anybody wants to have a quick chat or a quick sidebar. Any questions? Happy to stick around for as long as anybody wants. But enjoy your rest of the time. Enjoy the party tonight. Thanks all.